Okay, so this is my Lyman Briggs 274 final project on the electrical grid. So the electric grid, which is also known as the power grid, is the interconnected system in which electricity is generated and distributed to consumers. Basically how electricity is generated, used in everyday life, and everything in between. The three parts of the electric grid are generation, where the electricity is initially generated, transmission, where the electricity travels long distances away from the power plants, and distribution, where the electricity finally reaches the consumer. I was interested in choosing this as a topic because electricity is essential to our lives as it does everything from power our cities to our appliances that we use in everyday life. I thought it was something worth learning about and understanding. So there are two forms of generation for the power grid, which are decentralized and centralized. Centralized generation is talking about the large-scale generation for the masses. Types of centralized generation include coal, nuclear, natural gas, hydro, wind farms, and large solar arrays. And these operations are typically located far away from consumers because nobody wants to live next to these massive power plants that you see there. Decentralized generation is talking about smaller scale operations that are used or that are close to the consumer, such as like rooftop solar panels. So transmission distribution are the phases where electricity travels from the producers to the consumer. First is the transmission phase, where electricity travels long distances from those big power plants where it isn't generated initially. Um, So when this happens, it is first passed through a step-up transformer where the voltage is increased to a very large amount, and then it travels at this high voltage through transmission lines long distances to a local substation. And then at this local substation, the voltage is reduced by another transformer down to a magnitude that is usable by consumers. And then after the electricity leaves this final substation, the distribution begins where the lower voltage electricity travels through power lines, which are above or below ground, to the consumers where it can be used. So an interesting aspect we can look at with the power grid is the voltage changes that happen throughout the process. At the beginning of the process, the voltage is increased greatly before the transmission lines, and then at the end of the process, the voltage is decreased greatly before the distribution lines. So why does this happen? The reason that this happens is because we want to minimize the amount of power loss due to resistance. Because electricity has to travel a far distance, even transmission lines made out of efficient conductors will have some resistance which adds up over a long distance. As we see with Ohm's law, a larger distance and larger resistance means that there is a larger drop in voltage from the beginning to the end of the line. When plugged into P equals IV, we can see that this also results in less power. We can combine these two equations and get the equation P equals I squared R that shows the amount of power lost in relation with current and resistance. This equation shows that the best way to decrease the amount of power is to reduce the current. Going back to Ohm's law, we can see that the way you reduce the current while keeping the resistance the same is by increasing the voltage, which explains why we must increase the voltage to really high numbers for the transmission lines. So here we see the transmission lines versus the distribution lines. As you can see, the transmission lines are the really big towers that are in like rural areas. And then the distribution lines are the more common telephone poles that you see on the side of roads and cities and stuff like that. So here we can see that the big transmission lines on the left are going to be much greater in magnitude for voltage. We can see that they can be like 400 to 500 kilovolts plus, and they're really big towers, 100 feet plus tall. And then on the right, we can see the distribution lines for the last part, which are much lower in voltage, 115 kilovolts. Doesn't really get much higher than that for the distribution lines. And then here we see an example of the substations that are used to change the voltage. They use transformers in these substations to step up the voltage or step it down. So this is important for the future because There's a current interest in improving this system. The current electrical grid is a system that is dependent on infrastructure that's been in place for decades, and as a result, there are many areas for improvement. There's a current government project called the Smart Grid, which is looking to achieve multiple tasks such as create more efficient transmission of electricity, increase integration of large scale renewable energy systems, and look to make better integration of customer owner power generation systems, which includes renewable energy systems, like wind power plants, smart houses utilizing solar energy and solar panels and things like that. So it's really just a way moving forward to make a better power grid. And here are my references.